Scenario 3 Bioremediation of Chlorinated Solvents. Overview. This video demonstrates Scenario 3 Bioremediation of Chlorinated Solvents. Clicking on the SCN03 item provides detailed information about the simulation scenario. The simulation area represents a horizontal cross-section at the desired simulation depth within a rectangular area. Users can freely adjust the length and width dimensions. The default setting assumes a single hydrogeological material, defined by porosity and hydraulic conductivity. Users can input constant water head boundaries for both upstream, left side, and downstream, right side, or use site-specific water elevation data for configuration. The simulated pollutants are chlorinated solvents, including trichloroethylene, TCE, dichloroethylene, DCE, and vinyl chloride, VC. The model simulates dissolution, adsorption/desorption, and other geochemical reactions. The predefined chemical reaction network in this refined template uses lactic acid as a bioremediation agent for chlorinated organic pollutants. The reaction network includes three key processes: lactic acid fermentation, propionic acid fermentation, and non-dechlorinating microbial growth rates to describe fermentation reactions. Additionally, degradation reactions are modeled through a chain reaction involving trichloroethylene, TCE, and acetic acid. Users can define injection point locations, reagent concentrations, and injection methods. Next, click Load to open the Scenario 3 template. This will bring up the simulation interface for Scenario 3, where we can begin customizing the parameters as needed. First, set up the geometry. In this example, we are using the map feature, which is spatially accurate and based on real-world coordinates, to set up the simulation area. Click Map to open the map interface. Next, we define the simulation boundary. A rectangular area measuring 50 meters wide and 100 meters long, aligned at 0 degrees, is set. Right-clicking displays a green arrow indicating the center of the domain. Click Set Boundary to highlight the area with a red-filled rectangle. The map automatically divides the domain into directional zones, upstream and downstream. To define the sources, click on the desired locations, right-click, and select Set Source to place red markers labeled Source 1 and Source 2. Similarly, two injection points will be set up below gradient sources 1 and 2 by using Set Well to add green markers labeled Well, and Set View to add yellow markers labeled View to represent monitoring or observation points. Finally, close this map interface, and it will autosave. The geometry setting is completed. Then configure the mesh. Go to the mesh settings. Select the moderate option from the list, then, set the mesh density to 0.3. Define the parameters. Begin by setting the material properties for the hydrogeological layer. Select sand as the material, with a porosity of 0.35, hydraulic conductivity of 0.002 meters per second, and a density of 1.895 grams per cubic centimeter. Next, set the water table elevation to 3 meters upstream and 1 meter downstream, creating a hydraulic gradient that drives groundwater flow from left to right. Define the contaminant sources by assigning a TCE concentration of 0.5 mg per liter for source 1 and 0.3 mg per liter for source 2. Now, configure the injection scenario. Set the injection dose mass percentage for lactate to 0.05%. Specify a total dose for each well is 500 liters. Set the injection start day to day 50. Set the total injection time to 50 days, meaning the fluid is injected gradually from day 50 to day 100. Finally, define the total simulation period as 150 days, allowing the model to simulate long-term transport and behavior of the contaminant plume. Select the output method. Now, click Execute to run the model. The geometry results will first appear in the view window we configured earlier. Next, go to the Animation tab and click Play to visualize changes in velocity, pressure head, and concentrations of chlorinated solvents, TCE, DCE, VC, ETH, and lactic acid over time. In the plan view, arrows indicate flow direction, while color gradients represent water elevation and contaminant concentration. Finally, navigate to the View section to examine the simulation results at your defined observation point. Here you can analyze 3 types of data: velocity, pressure, and concentration values for each chemical compound, TCE, DCE, VC, F, and lactate. Finally, visualize and interpret the results in the site. Management GUI. Clicking on the Site Conceptual Model Information GUI opens the main interface. On the left, the resource browser allows us to toggle data layers such as pressure, velocity, and concentrations of chlorinated solvents and lactic acid. In the center, the render view shows the simulation domain, with red areas on the color map indicating high TCE concentrations near the source. At the bottom, the spreadsheet displays simulation data for each node, including coordinates, velocity, pressure, and concentration, helpful for validation and analysis. To add a map, right-click on New Map, choose Input EPSG, then click OK. A new window will open, and we can see the results displayed on the map. In the left panel under the Resource Browser, expand the Vis Animation section. You will see various simulation outputs, including pressure, velocity, and concentrations of TCE, DCE, VC, F, and lactate. At the bottom left of the interface, you will find the Properties Editor, which contains 2 separate windows. The first window displays information about your current view, whether it is the render view, map view. The second window provides adjustment controls for the Vis Animation section, allowing you to modify the color map, information display, rendering settings, scale bar and text options, and translation parameters. Simply check the box next to the variable you wish to visualize. Once a variable is selected, look below at the Properties Editor panel. To better visualize your results, start by adjusting the display mode of the render view to surface with opacity equal to 0.8. Then change the color scheme to plasma. These settings will help you interpret the results more clearly. Once you've made these adjustments, return to the render view and click play to start the animation. This will allow you to visualize the animated results in both the render view and map view simultaneously. Thank you for your watching.